History of programming languages. The history of programming languages reflects the evolution of technology and the increasing need for humans to communicate effectively with machines. Here's a brief overview of the major milestones in programming language history. 1. Early mechanical programming, 1800s. 1801. Joseph Marie Jacquard created the Jacquard loom, which used punched cards to control the weaving of patterns into fabric. 2. 1837. Charles Babbage proposed the analytical engine, a mechanical computer, and Ada Lovelace wrote the first algorithm intended for it, making her the first programmer. 2. First generation. Machine code, 1940s–1950s. 1. Machine code consisted of binary, ones and zeros, instructions directly executed by hardware. 2. Key characteristic. Extremely difficult to program and understand. 3. Second generation. Assembly language, 1950s. 1. Assembly language introduced mnemonics, e.g., add, sub, for machine instructions. 2. Required an assembler to convert it into machine code. 3. Simplified coding but was still hardware specific. 4. Third generation. High-level languages, 1950s–1970s. High-level languages emerged to make programming more human-readable and hardware-independent. 1. 1957. FORTRAN, formula translation, designed for scientific and mathematical computations. 2. 1958. Lisp, developed for artificial intelligence research. 3. 1959. COBOL, common business-oriented language, focused on business applications. 4. 1964. BASIC, beginner's all-purpose symbolic instruction code, created for educational purposes. 5. 1970. Pascal, aimed at teaching structured programming. 5. Fourth generation. Declarative and specialized languages, 1970s–1980s. 1. SQL, 1974, for managing and querying relational databases. 2. MATLAB, 1984, focused on numerical computing. 3. Prolog, used in artificial intelligence for logic programming. 6. Fifth generation. Object-oriented programming, OOP, 1980s. Object-oriented programming focused on encapsulating data and behavior into objects. 1. 1980. Smalltalk, pioneered OOP. 2. 1983. C++ combined the efficiency of C with OOP principles. 3. 1995. Java. Write once, run anywhere. Wara, philosophy, popular for web and enterprise applications. 7. Internet age and scripting languages, 1990s. With the rise of the Internet, scripting languages became crucial for dynamic web development. 1. 1991. Python. General purpose, easy-to-learn language. 2. 1993. Ruby. Focused on simplicity and productivity. 3. 1995. JavaScript, for interactive web development. 4. 1995. PHP. Designed for server-side web development. 8. Modern era. Multi-paradigm and functional programming, 2000s present. Modern languages emphasize scalability, concurrency, and ease of development. 1. 2001. C#, developed by Microsoft for enterprise applications. 2. 2003. Scala, combines object-oriented and functional programming. 3. 2009. Go, Golang, optimized for system-level programming. 4. 2010. Rust, focuses on safety and performance. 5. 2014. Swift, Apple's language for iOS and macOS development. 6. 2019. Dart, optimized for building user interfaces, popular with Flutter. Key trends in programming language evolution. 1. Higher abstraction. Languages are becoming increasingly human-readable. 2. Specialization. Languages are tailored for specific domains, e.g., R for statistics, SQL for databases. 3. Cross-platform compatibility. Emphasis on languages like JavaScript and Python that run across different systems. 4. Security and performance. Modern languages like Rust prioritize memory safety and concurrency. Each era of programming language development has contributed to simplifying the interaction between humans and machines while enabling increasingly complex applications.